This is Sal here, and I'm at Stanford Medical School with Dr. Andy Connolly, who's a pathologist here, and this is the second in our series on looking at some of these slides.
Yeah, so we left off last time, Sal, looking at this piece here, which is normal colon. We had said this is an example of what you'd see at the edge of a specimen release for colon cancer. Now I'm going to click to the next one, which is a slightly more worrisome area if you're a pathologist looking through the colon. And so I'm going to zoom in just a little bit here to take a look at these.
Looks very worrisome compared to the last one.
And so what we don't like about it is we saw before, this is what the normal gland looks like. It's a test tube shape and goes down, and it has these cells which are normal. Now all of a sudden it looks a little thicker here. And what catches our eye also is these aren't just straight test tubes anymore. They divide. They kind of go in and out like that.
So, but they still are test tubes. I mean, just following up what we said in the last video is that they just look like circles as opposed to test tubes because we're taking a cross section because they're kind of popping out of the two dimensions.
That's right. But although when you come from the surface here and you go down,
not
they normally should never branch.
I see.
And so these ones are branching, and that's always bad.
Right.
And then you can see the way when you're putting a cross section, there's normally just a little hole in the middle, and that's where the mucin. You can even see it spilling out there. The mucin. So you can see it just kind of coming right out of there. This one here looks different, and what it is, it's piled up. And so it's a little bit bigger around, and in order for these cells, there's more cells. They're going to be all piled up and going like this, and they even branch. And so what this is that we look a little more closely at this piece, and we say, I wonder if that's cancer. Could it be precancer, or is this just an area of irritation? And a common response of the body to irritation is some sort of change. And like we were saying before, epithelium is the top layer.
And so it's facing the outside world.
Facing the outside world. So if it's irritated, often the epithelium will change. And in this case, it's changing by undergoing more growth.
Is it always, even if it's non-cancerous, is it like it's going to be a higher likelihood that it's going to become cancerous in the future?
A lot of cancers, it appears in the body, come from parts of the body that are either irritated or have some sort of environmental challenges that are constantly at them. And part of that is because there's a lot of cell division. If you keep dividing a cell, you might have errors in the DNA.
So that's why skin cells, bowel cells.
That's right. And even things like liver. If you keep damaging your liver, you might have ongoing things in liver cancer. So when you're looking here, the pathologist would look at this area and say, well, it's a dividing gland that's kind of thrown up in these areas. But largely, they're still making mucin, or they're this type here, which looks like it's tall and probably absorbing water.
So even within these test tubes, they're not really test tubes, but inside of these vessels, there are also the absorptive cells as well.
That's right. So here, this is we would sign this off as hyperplasia.
Hyperplasia. So hyper, like too much of something. And plasia.
Growth.
And
so plasia just means growth. And so hyperplasia means too much growth. But the important thing is if you took away the irritant, it wouldn't do this. So if you took away whatever the irritant is for the hyperplasia, it would go back to being normal.
I see. And this is something we know.
That's right.
And there's some stimulus that was causing these cells to do that. It might have been diet. It might have been some chemical. It could have been just...
We're never really sure what, because so much of it is things that just float on through and come through. So it's really hard to know. But this is probably too much growth in response to an irritant.
So it's possible that it just happened to be when this section of the colon was taken out. If this was done a day later, then maybe this might have not been there.
Yeah, probably take a longer than that. A couple of weeks. Because what happens is that the cells come from the bottom and they work their way up towards the top. And so eventually the top would behave.
And so the way the body works here, and it's kind of like the skin, is this constant. These cells are being used up because things are being kind of scraping by them, and they get a lot of kind of use.
They do,
and
in fact,
there's a constant stream of.
There's a lot known now about stem cells, and the stem cells for the intestine are these guys.
Oh wow! So how do you differentiate that as stem cell versus?
There's a at the very bottom, the bottom hemisphere. There are going to be cells there that do not have the open chromatin and are kind of elongated. There may be ones which are endocrine cells, meaning they release hormones. And so they may have hormone-releasing cells, but in this bottom hemisphere, that turns out to be where the intestine keeps them, and these guys are probably these stem cells.
And just as stem cells are undifferent, cells that haven't kind of picked their jobs yet.
They haven't, and so there's all kinds of stem cells. There's the stem cell that can make a whole body being.
Exactly.
But then there's also the kind that can make the rest of the colon.
I see. Right.
And so
right.
this one is probably the stem cell that can make the rest of the epithelium,
right,
but these
right.
two different kinds.
The two different types, right?
Yeah, so they're down here at the bottom. That's about where you'd want them.
Exactly.
So,
right.
So that makes sense. So down there are your stem cells, and it grows like that. So this is a hyperplasia.
Wow.
So I'd like to show you next the next step, which is the precancer lesion.
Okay.
Should we do that in another video?
Yeah, let's do that in another video.
Okay.